Yep.
Hi, I'm Ella.
And I'm Julianne.
And this is our math video. Okay, the concept of our video is the sums of radicals.
And this section is found in section 3, chapter 6. Our objective is
For you to learn
the sums of radicals.
So our topic is the sums of radicals, so we're going to go over some vocab real fast. You'll notice that we use this a lot, and that's called the radicand, and it's used when taking the square root of something. The square root is what times what equals that number, and they're the same number. So for 9, it would be 3 times 3, 4 would be 2 times 2, and 25 would be 5 times 5. You can simplify radicals many ways, and we'll show you some of those ways in the problems that we do.
it's math is fun.
Even in the hallways! Problem number 1 is radical 8 plus radical 98. The first step is you break it up into radical 4 times 2 plus radical 49 times 2, because these are the factors that make up 98 and 8. And if you notice, 4 is a perfect square root, so you can pull the 2 out of 4, so you're left with the radical 2, and then 49 is a perfect square root, so you can pull out the 7, and you're left with the radical 2. And then you notice that the two numbers have the same radicand, so you can add them straight across, so you would be left with 9 radical 2 as your final answer.
I love math.
Okay, problem number 2 is the cube root of 81 minus the cube root of 24. Your first step is going to be to break up the numbers inside the radicand. So you're going to have the cube root of 27 times 3 minus the cube root of 8 times 3. The next thing you're going to do is you're going to notice that the cube root of 27 is 3, because 3 times 3 times 3 is 27. So you're going to pull the 3 out, left with the cube root, and you're going to be left with the 3 that was inside the radicand. Next, you're going to notice that 2 is the cube root of 8, so you're going to pull out the 2, left with the cube root, and the 3. So once you've done that step, you notice that 3, well, there's like the same denominator or same radicand, so you can just minus straight across. So you'll notice that you can just do the 3 cube root 3 minus 2 cube root 3 is really just 1 cube root 3, and you don't have to write the 1, so your final answer will be the cube root of 3. Okay, problem number 3 is radical 32 over 3 plus radical 2 over 3. Your first step is going to be to multiply everything in the radicand by 3, because it will help us later on. So you're going to write it like that, and you're going to do the same thing to the other side. So it should look like that when you're done. Then you're going to do the multiplication. So you're left with radical 96 over 9 plus radical 6 over 9. And you'll notice they have the same denominators and everything. Next, you're going to put each number in its own radicand. So it's going to be 96 over radical 9 plus radical 6 over radical 9, and the radical, or the square root of 9 is 3. So you're going to have a denominator of 3 for both problems because they were both square root 9, and you're going to split up the 96 into 16 times 6, leave that in the radical, and you're going to still have the radical 6. You know that the square root of 16 is 4, so you're going to pull out the 4 and be left with the radical 6 over 3, and then the radical 6 over here over 3. You know that theoretically there's a 1 right in front of there just because there's 1. So since they have the same denominator and the same radical, you can add the 4 and the 1. So your final answer should be 5 radical 6 over 3.
You gotta turn around.
Okay, problem 4 is radical 21 plus radical 15 over radical 3. The first step you're going to do is to split the fractions in half and put the 3 in its own radical. So it's going to end up looking like radical 21 over radical 3 plus radical 15 over radical 3, which is the same thing as before. It just is easier to write out. Then you're going to put everything under one radical, so 21 over 3 plus radical 15 over 3. And 21 divided by 3 is 7, and 15 divided by 3 is 5. So you're going to end up with radical 7 plus radical 5, and that's as simplified as it can go, so that's going to be your final answer.
That's pretty good, alright? So, you do some very
Radical 6y minus radical 3 over radical 2. The first thing you have to do is do radical 6y minus radical 3y over radical 2 and times it by radical 2 over radical 2, so you can get rid of the radicals as the denominator because you can't have a radical as a denominator. After you do this, you then get radical 6y minus radical 6y over 2. Because when you multiply radicals, the answer still stays inside of the radicals. So you get 6y, and then when you multiply radicals by themselves, like a radical 2 times radical 2, you end up just getting 2. After you do this, you then can put the whole equation over 2, but in order to do this you have to multiply 2 in front of the first 6y. So then you get 2 times radical 6y minus radical 6y over 2. And to simplify this, you then get, since you have 2 radical 6y minus 6y, you're just getting rid of one of those 6y's, so then you're left with radical 6y over 2. And that's as simplified as your answer can get. So that's your answer.
Just met a boy when he could come inside of my playpen, cause he looked like a superstar in the making. So I think that I'm going in for the taking. Hear through the grapevine that he caking. We could shoot a movie, he could do the taping. Boom, 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 pow, this thing be shaking. I ain't even try to find out who he dating, cause I know he got